This screencast is on the effect of structure of your molecules on their acid-base properties. Acid strength increases with the number of oxygen atoms on your central atom. So if we consider these Lewis structures for hypochlorous acid, chlorous acid, chloric acid, and perchloric acid, notice that as you go from left to right, there is an increasing in the strength of the acid. Now, perchloric acid happens to be one of our 6-pack of acids, one of our 6 strong acids. These other 3 are weak acids. However, if you look at the number of oxygens on the central atom, in this case, we're calling the chlorine the central atom. In hypochlorous acid, there's only 1 oxygen on the central atom. It's your weakest. The acid strength increases with the more oxygens on the central atom. Look at your chlorine here. He has 2 oxygens. This chloric acid has 3 on the central atom. And then, of course, perchloric has a total of 4 oxygens on the central atom. So if you consider the structure of your molecule, of an acid in particular, the strength of your acid will increase with the increased numbers of oxygens on that central atom. So of these 4 acids here, hypochlorous acid is your weakest, and then of course perchloric is your strongest. Here is the hydrogen ion that the acid would donate. This is the acidic hydrogen, as we call it, that would actually be donated in the acid-base reaction. So when you're considering the strength of the structure of your molecule on the strength of your acid, the increased number of oxygens on your central atom indicate a increased strength in your acid. Now, second thing we want to consider are the acid-base properties of compounds that are called oxides. If your oxide has an OX bond that is strong and covalent, then the oxide is considered acidic. So an oxide is a compound, obviously, that contains oxygen and another element. So X could be any element from the periodic table that would bond with oxygen. And he does bond with a lot of other elements. Element X in this case would be a very electronegative element. Now remember, as you go up and across the periodic table, electronegativity does increase. So if X is a very electronegative element bonded to the oxygen, that also means that it would be a nonmetal usually. These are going to be with your nonmetal oxides. Some examples of these would be like sulfur trioxide and nitrogen dioxide. Notice these are oxides that have a nonmetal. Your oxide will be basic if the OX bond is weak and ionic. Remember, ionic compounds contain metals plus nonmetals. So that means it would be a metal plus oxygen. Element X would have a low electronegativity. So again, it would be a metal with oxygen. Some examples are like sodium oxide and calcium oxide. One way I've always remembered the basic oxides is if you think about your strong bases, bases tend to end in OH. So some bases we're familiar with would be like sodium hydroxide, potassium hydroxide, lithium hydroxide, calcium hydroxide. Think about these strong bases and notice they all contain metal with hydroxide. Those are our bases. Well, your oxides, if they're metal oxide, are going to be your basic oxides. So if you were to put these in water, it would actually form, like, for example, sodium oxide in water. Whenever it would dissociate, would form sodium hydroxide. All right, so this is the end of this screencast. You should be able to use the information from this screencast to help you with tonight's homework.